2 or something. All right. Okay, we are live. If you want to walk into the frame, you can walk into the frame.
And do I speak into that mic?
If you speak into the mic, it's probably gonna come out more clearly because it's louder. So yeah.
Okay, sorry.
You're not in the frame.
Sorry, everyone. Okay, so we're going to be hosting an integration contest today from 6 to 7 in ES4000. This is just for YouTube, by the way. And if you want to show up, feel free to. There will be free snacks, and yeah, it's going to be hopefully a chillish time. All right, thank you, everyone.
All right, thank you. Yeah, I went last time. It was pretty chill. So yeah. No, I was just like watching, like it's not, you know, like why compete if you're gonna lose? It's not Wordle.
You can integrate my formula.
Nah, I can like integrate with Mathematica. Yeah. So the best integration for the things that you can integrate is a solved problem. And the algorithm is like not even that bad. It's like, I think it's like O of n to the 4th or something. All right. Reprojecting? Yeah. Not projecting? Okay. Yeah. Hi, everyone. So what I'm gonna do today, again, I realize that this is kind of like nitty-gritty details in some ways, or maybe it looks that way. But at the same time, like if you don't know those details, you just cannot code in C at all anything that's kind of complicated. So like we got to do it. So the lecture today is going to be like, I'm still going to type, but it's basically a Blackboard lecture. So you should treat it like it is a calc lecture, where if you don't copy and write yourself, it's probably not going to be useful. So what we're going to do is just like variations on arrays of structs, like various arrays of structs. Stop me at any point if things are unclear. There are supposed to, at this point, be crystal clear because we know all the rules. So we have our two. All right. So like the other thing, so the people in the back, if this font is too small for you, I would ask you to come to the front, because if I make the screens larger, there's like a trade-off of not being able to see anything, or like not being able to see like the things that they want to show at the same time. So, okay. So we have our struct student, and they have a name like this. We'll name this student 1. Hello, Chris. And we have the age, and then we do a type def for that. And that's going to be student 1. So student num is gonna student 1, sorry, is gonna have a character array as the name. And then student 2 is gonna have a character pointer as the name, and the age is going to be the same. So that's student 2. So, okay. So what are the differences in terms of just looking at those two structs? Well, the differences are what you are allowed and not allowed to do in terms of changing the name. So change name 1, let's say. And that's going to take a student one S1 like this. So you are not allowed to do this. So not allowed. Didn't say one here. Because cannot assign to arrays. strcpy is allowed. So there's two things that are going on here. So one, you are allowed to write Michael into a 200 character array, right? That there's enough space there. And you are allowed to modify the contents of arrays. So that is completely okay. Right? So if you take a student 2, then that is now allowed. Because you can change the value of address name to something else. So specifically what you're doing here is you're saying, I'm going to take this, which is an address. It's a car star name. So it's an address of where a string is stored. And you're saying, I'm going to make this address be the address of this lowercase m. Right? So that is allowed. So whether strcpy is allowed depends. Right? So what does it depend on? Sorry, this is S2, of course. What does it depend on? Well, it depends on whether you can or cannot write to the address S2 name. And sometimes you are, sometimes you aren't. Right? So specifically in the situation here where the code is like this, you are not allowed to do this. And that's just because I just made S2 name be a pointer to a string literal. You are not allowed to modify string literals. Okay, so if S2.name is actually an address of a string literal, this may crash. If not, then it could be fine. If S2.name is a memory area where you are allowed to write, and there is enough space, which is 5 characters, because 4 plus the null. Then that is fine. Make sense? So just looking at this code in isolation without this might be fine or it might not be fine, depending on what you did before. Does that make sense? So let's say that we're looking at change name like this. And let's make an external student2 where this would crash and where this would not crash. So I'll do S2 S2. Sorry, I wasn't like super consistent here because, and this is like, so I didn't do like P underscore here. I'll keep it that way because that is arguably the more usual way of writing it. But here S2 is going to be different. So let's name that something else like ST2 so that we're not making a duress out there. So if I make ST2 like this, and then I say change name to a duress of S2, is this fine or is this not fine? Anyone?
Yes.
Hello.
I'm here for the battery.
Thank you very much. No, I'm here for the battery. Thank you. All right. So if you're doing this, is this fine or is this not fine as it stands? Who says it's fine? Who says, okay, who says it's not fine? You're right. One thing that you'll find out if you apply for the PEng eventually, there is an ethics exam. And in the ethics exam, they describe a scenario, or like several scenarios to you. And they ask you, like, is it ethical or is it not ethical to do the thing that we are proposing that you should do? So the trick is you should always say no, because well, like, you can't imagine like coming up with a scenario that's like completely clean. It wouldn't make sense. So like the only way to ask this question is to have like a reason in mind that it wouldn't be ethical. I found it out as like I was like looking at like the sample problems in the test. And like they do trick questions. Sorry, this is a distraction. I want to tell you about it. It's relevant to your life, possibly. So this scenario, I think it's still online. So this scenario is you're working at the firm and you're a junior engineer, and there is like a senior engineer who's known to be a bit of an ass, who is like having a fight with a client about their project. And the boss comes to you and says, like, there's like a fight there. Could you help me out, please? And like take a look at the project and see what's going on. But please keep it like hush hush. Don't tell that guy, because like there's gonna be more of a fight. Are you allowed to do that? The answer is definitely not. According to the Ontario Professional Engineering Act, as a professional engineer, you absolutely may not take over a project that another professional engineer is working on without their consent, even if it's gonna be a fight. So the correct thing to do, I take it, would be to go to the senior engineer and work it out. And if they refuse to collaborate, then they could be fired maybe, and then you can take over the project. So that is my understanding. Don't quote me on that, but that would be my understanding of how you resolve it. Anyway, why is this not fine? So what's going on here is you are defining a student2. So that's the student2. I did not initialize student2, right? So that means that st2.name is some random number. st2.age is also some random number. So you're trying to write something to a random address. You're not allowed to access a random address, right? Does that make sense? Okay. Let's say we initialize it. You can initialize a student with the curly braces notation. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Is that okay? Who says it's okay? Who says it's not okay? What did it tell you? The answer is always no. So why is this not okay? Well, so now st2.name is the address of the M in Michael, but Michael is a string literal. Not allowed to modify string literals. That could crash the code. Make sense? All right. Let's say that I really want to write change name to address of st2a and have it not crash the computer. How would I make it work? We are over here. I want to eventually say this. And I want it to be okay. Ideas? So what do I want? I want for st2a dot name to be a valid address to which I can actually write. How can I do it? Yeah. Mm-hmm. Yeah. Yeah. So there is so that's a way to do it. So I was gonna do it over here, but that's like actually I'll do it your way in a second as well. But I'll do it kind of your way. So I'll just say, car name is Michael. And then I'll say st2a dot name is equal to name. So it is now fine, right? st2a dot name is now the address of the in the array name. And you're allowed to modify array contents. Yeah. Another way of doing it is to create a malloc allocated block. So that's basically the same idea. So I'll say like car name 2 is a block of cars. Size of car is always 1, but might as well write it. I'll give it like a generous 200. I can do whatever I want. I could write Michael in there. I don't have to even. I can just say change name, address of st2a after I said st2a name is equal to name 2. And that would be completely fine. Makes sense? Right? Here is a way to make it not fine. So if I just take this and copy it and just allocate 2 cars, that is now not fine. So when we're writing ke null, potentially writing outside of the block. So that could crash. Worse, it could be that you're modifying memory that you're actually allowed to modify. It's just that it's being used for something else in your program. So it could completely mess you up. Does that make sense? Questions? All right. So this is like this. So one way to avoid some of the problems is to define this kind of stint. So if I just have a const car name, what it's going to do is it's going to avoid situations, some situations where I'm not the strcpy, but it's going to avoid some situations where I'm going to be trying to change the name a little bit. Right? So if I do something like this, I'll do student3 s3. So I can now safely initialize it like this. Did I change this to student3? No, I did not. So I can now more safely initialize it to a string literal because I literally said it's a const car. So if I try to say s3.name at 0 equals to m, that will just not compile. So let me comment this out. So what's happening here is it's saying you have a problem. You are not allowed to modify s3.name at 0, which is great because if it weren't a constant, it would compile. It's just that it would crash later. So you can also try to say, I'm going to change the name. Consistent. So I'll say address of SD3, like so. And we're waiting for it to probably crash. Yes. So what happened is strcpy does not check for you, hey, like, am I writing to a const? Now, what is true is if you click to the problems tab, it's going to warn you that there is probably a problem. So here, what it says is you're passing ST3. Sorry, that's a separate issue. Sorry, I'll change it to ST3 because I did not make it ESTN3. Like this, I'll get rid of the warning for strcpy. That was just including string.h. I was still calling change name to. Like this. ST3 undefined, it's not undefined, it's fine. Hold on, sorry. Right? And now our okay. Now it's gonna crash finally. Great. So we crashed over here. We also have the warning here. So the warning is we are passing S3 name, which is const, to strcpy, which expects a non-const. However, that's a warning, not an error, so it will compile. Sorry, so from the top, what we did here is we said, okay, student st3 is of type student3. So student3 has a const car star as the name. That means an address, but an address where you're not allowed to modify the contents. If you go and you directly change the contents, like so, that will be a compilation error. That's the point of const car. However, if you do it using strcpy, what you'd get is a warning, not an error. It will compile, it will run, and then it will probably crash because you would be writing to a const car. So strcpy, you can call it with a const car star. It'll convert silently. It'll then potentially crash. Make sense? All right. Questions about this? So let me move this stuff closer to student 3 so that we can see it all together. This is like this. And what we're this is like an old thing because this is actually commented out. So a lot of the time, if it's like underlined, it's underlined because of like a recent version. So now I saved it and now it's not underlined. The only thing that's underlined is this. So the underline here just means if you try to compile it, you'll get a warning. And the warning would be you are passing what looks like a const car star to strcpy, which actually expects to be able to write to this destination. All right. Okay, are you with me? So like, I know this is like complicated. I think kind of the way to do it is to like write it yourself and then practice, which you'll have an opportunity to do in terms of practicing. But like writing it yourself right now, I think just like writing it down or like copying it down could be helpful. Depends on the person, of course. All right, questions about this? Are you fine with this? Because we're doing a new thing now. All right. I'm doing a new thing. So let's say that what I want to do is initialize something like student2. So student2 is over here. I'll move it so that it's next to the name. So I want to initialize something like student2 in the way that you would initialize the thing with the array. That's not as easy because with the array, you just initialize it with the curly braces and it's fine. This one, if you initialize with a string literal, that's going to be trouble, right? Because this one, you're supposed to be able to modify the contents of name. It's a car star. But if you initialize it with a string literal, it will potentially crash eventually. So the way people usually do it is by writing a function that's basically like a create student function. So we'll call it like a create student2. And there's multiple valid ways of whether you return something or whether you create something. So in this case, I'll make it a void create student2. And I'll pass an address of a pointer to student2 to it. And I'll pass a name. And I'll pass an age. And then I'll initialize it. So the way I want to make it work is I want to be able to say student2 S2 over here. And then I want to be able to say create student2, address of S2. And I want for S2 with the name, of course. And I want now to be S2 to be a pointer to a student with the name Mike and age 31. Make sense? So that's what I want to do. So if I want to make it the case that S2 used to be nothing, I did not initialize it, and now S2 is a valid pointer, that means that I got to do like malloc stuff in the function. And if I want to modify S2, that means that I got to pass the address of S2. So that's why this guy is going to be of type student2 star star, because I'm passing the address of a student2 star. Yeah. So, okay. So the first thing I'll do is I'll make star PS2. So that's the same as S2 in main. Be the address of a block of one student2. So now I'm allowed to write to star PS2 name and star PS2 age. So the age is easier. So this is of type student2 star. So that's an arrow. So that's going to be like this. Does that make sense? So the reasoning here is PS2 is a pointer to S2. So I treat star PS2 as if it were S2 because it is. Right? So this star PS2 is this S2. And if I want to set the age in a structure which is pointed to by S2, I do S2 arrow age. So same thing, I do star PS2 arrow age in here. Right? So now I've passed Mike to the function. So I have the contents, but I want to write it to a writable block so that I can modify it later with strcpy and whatever. So I need to create it first. So I'll say PS2 name is a new block to which I'm going to copy the name eventually. But first I need to be able to actually write to that block. And the way I'm going to do it, at least here, is I'm going to say it's going to be a block that's of length, the length of the name, which I'm going to write to it, +1. Why the +1? Yeah. Because of the null, exactly. So the amount of space that they need in order to write Mike is 4 + 1. So now that they have this space in memory to which I can write, I can say, okay, so copy the name to this guy. All right. Does this make sense to does this not make sense to someone? Once more. All right. So the point of this is that now this is initialized and I could do whatever I want. So I can like print the name or something. So this would be like S2 name. Let's run it so that make sure that, oh no. Stint2. No, I just defined stint2. What do you mean? I definitely did not mean stint3. Oh, I see. So the issue is I wanted to move the definition of the struct, but when the function is defined, it has like stint2 has not been defined above it. So I just am moving this function below the definition of the struct. Okay, so it printed Mike. Let's see what the warning is. So this is the warning from before in change name 3. That is fine. We know that's a problem. So malloc and printf, those warnings are for not including stdlib, which has malloc and also has null. And this is for printf. So the issue is that on Linux, it compiles anyhow. On different systems, it might not if you don't actually kind of explicitly include those. So if we run this now, we'll get the warning about change name 3, but that's change name 3. Change name 2 is completely fine, and it prints Mike. And moreover, we can now safely say S2 name at 0 is M, and print the name again. And that's completely fine and will not crash. Make sense? Okay, so 2 more things that I want to do, and then I'll let you go. So one, we've created this thing which says create student. So that called malloc twice. We want to avoid memory leaks. We want to also be able to free all the memory that was created there. So just by convention, you can call those functions whatever you want, but it's usually referred to as destroy student2. So this would be a function to free all the mallocs that were done there. So because we are not modifying the student, we don't really need to send the address. We can just send just the pointer. So whatever, like that is how, no. That was a funny joke, come on. Okay. So what you actually want to do is you want to free the name like this, and then you want to free S2. So the order here matters because you're not allowed to access contents at S2 once you freed S2. So you cannot free S2 and then try to access S2 name. But you can first say, I want to free the memory that was allocated to the name. Once I freed the memory that was allocated to the name, I can say, I'm going to free S2 itself, and that basically corresponds to freeing the block that was allocated here, and then freeing the block that was allocated here. Make sense? So after you're done using S2, you can say free S2. So there is, and like it depends on like the person's taste, whether you want to make this symmetric or not. So this is address of S2 because you have to send the address of S2 in order to be able to modify it. This is just S2 because you don't actually need to modify S2. You just need to use it in order to free the memory blocks that are associated with it. You could send the address of it. That would not be a problem. You just have to change destroy student 2 to like star PS2 instead of saying S2. That would be the same. It's like up to you which way you prefer. Yeah. So the reason you need a pointer to a pointer here is that you are wanting to, so S2 starts out being just a random number here. You want for the effect of create student 2 to be that S2 becomes a valid address of a student. The only way for S2 to become anything at all is for you to send the address of it to a function. And then because S2 initially is of type, well, it's always of type student 2 star, so the address of S2 is of type student 2 star star. All right. So that's like that. The other thing I want to do is do a different version of create student 2. It's just that you'll see both kinds. I kind of prefer this one, but you could also say to your question, I don't like pointers to pointers. If you don't like pointers to pointers, what you can do is you can just return a pointer to student 2 rather than modify a pointer that you pass to the function. So this would be create student 2 v2. And this would be just so this would be just const char name and age. So I'm not passing anything here. I rather am returning a pointer to student 2. So what I'll do here is I'll just create S2 in here. So that would be exactly this. I'll just copy and paste it. And instead of PS2, I'll just say S2. And I'll say S2. And I'll say S2. And then once I'm done, I'll return S2. Right, so those are basically the same, except here I'm saying I'm going to give you a pointer to S2, modify S2. Here I'm saying return S2. So to create a student with V2, rather than saying this, I'll do this. Right? So the analogy here would be you can do like a change A like this. Or you can say, so this is void. Or you can say like int like this, and you can say outside of this, like A is equal to red 42. Right? So you can either pass a pointer to the thing and modify the thing inside the function, or you can just get the information via the return mechanism. Those are like they're doing the same thing. Different people do different things. You'll see both. Functionally, they do basically the same thing. All right. Questions about this? All right. Thank you very much. I will see you tomorrow. I'll now do the Wordle, which I forgot to do. Thank you. Yeah, you don't have to stay for that. Thank you. Hello.
ESC190 exam, I got regraded.
Okay.
So I can update that on take or no? I need to submit a request through.
No, I'll take a look. So I haven't actually checked those yet, but I will. Yeah.
Thank you.
Mhm.
I was just wondering if you were submitted from.
Yes.
Awesome.
Yeah. You're Javier, right? Yeah.
It's gonna be like quiz today, right?
Yeah, I like ran out of time. Yeah. Yeah. Bye.